Hello students, welcome to EC Elimu Learning Simplified and welcome to this lesson. In the previous lessons, we discussed quantities and we said we have two types of quantities and they are categorized in a way that one cannot be obtained from other physical quantities and we call them basic quantities. We have the other one that can be obtained from other physical quantities and we call them derived quantities. Now in this lesson, we are going to discuss one of the derived quantities, that is area. My name is Albert. I hope you are enjoying the lesson. By the end of this lesson, I expect you to be able to define area and state its SI unit, give the multiples and submultiples of area, and then calculate the area of regular shaped objects, and then finally calculate the area or estimate the area of irregularly shaped objects. Area refers to the measure of an extent of a surface. It's a derived quantity. Derived quantity, remember we said these are derived quantity. Derived, we said quantities that is only obtained by either multiplication or division of other physical quantities. Now, what are we going to do to these other physical quantities for us to get area? It's a derived quantity of length. So the physical quantity that we are going to use to obtain area is length. Area, we are going to get it from length. Now, are we going to divide length for us to get area, or we are going to multiply for us to get area? Now, let's look at the SI unit. The SI unit of area is a square meter. Now, if length, its SI unit is meter, which is written as m. What are we going to do to m so that we get square meter, or a meter squared? Then what you're going to do, you're going to get m, which is length, times another length, then you're going to get m squared. So now, for us to get area, we are going to multiply length times length for us to get length squared. So that is will give us, if we write in simples, that will give us m. Length is measured in meter and is written as m, and then multiplied by another m, which is length, to give us a square meter. So the SI unit is square meter and area is obtained by multiplying two lengths. Sometimes area is too big to be measured in square meter, and sometimes it is too small to be measured in square meter. So it is important to have some other multiples and some multiples which are going to help us to measure two big areas or two small extents of a surface. Now, some of the multiples and some multiples that we have is 1 square meter is equals to 1 million square millimeters. Now, is this true? How can we prove that? Remember, we said in the conversion of units of length, 1 meter is equals to 1000 millimeters. Now, if we have 1 square meter, it means it's 1 meter times 1 meter, which is the same as 1 square now millimeter. It will be times 1000 millimeter times 1000 millimeter. Now, 1 times 1 is 1, meter times meter is a square meter. 1000 times 1000 is 1 million, and then millimeter times millimeter is square millimeters. So from this case, we can prove that 1 square meter is equals to 1 million square millimeters. The second interconversion is 1 meter or 1 square meter is equals to 10,000 square centimeters. How can we prove that? We said 1 meter from length is equals to 100 centimeters. Now, if we have 1 square meter, it means it's 1 meter times 1 meter, which is the same as if we square 100 centimeters, it will be times 100 square centimeters times 100 centimeters. So now 1 times 1 meter, meter times meter, meter squared or square meter, which is the same as 100 times 100, it's 10,000 centimeter times centimeter, it will be square centimeters. So as you can see, we can even prove that these interconversion are correct. Now what I want you to do is go and find out that if 1 million square meter is the same as 1 square kilometer. That is your assignment as a student. So let's do an example so that we see what we have been learning. And the first question is express the following into square centimeter. So the first thing a student should do is first convert whatever you have into SI unit before you can convert it into other units. For example, in this case, the first one we have been given in square kilometer. So we must first change it to SI units. SI units of area is square meter, which is written as m square. So we must first change this one into square meter. And the relationship between a square meter and a square kilometer is that 1 square kilometer is equals to 1 million square meter. Now if we have been given 0.00052 square kilometer, how many square meters will be there? If we could multiply, then we will get 0.00052 square kilometer times 1 million square meter over 1 square kilometers. Then if square kilometer cancel out with square kilometer, then it means our answer will remain in square meter. And this one is going to give us 500. Let me use a blue pen. It's going to give us 520 square meter. Now, after we have converted it to square meter, then now we can convert it to square centimeter. Remember we said 1 square meter, 1 square meter is equals to 10,000 square centimeters. Now if we have been given 520 square meter, how many square centimeters are there? Then if we cross multiply this, we will get 520 square meter times 10,000 square centimeter, then divided by 1 square meter. Now, if square meter goes with square meter, then it will mean we will remain with an answer in square centimeter, which is going to be 5,200,000 square centimeters. So that is our answer for question 1. And now if we go to question 2, this was question 1. Question 2, it's requiring us to change 10 10.5 square meter to square centimeter. Then what we do, this is already in SI units, then we just write it directly. If 1 square meter is equals to 10,000 square centimeter, then 10.5 square meter, how many square centimeters will be there? Then if we cross multiply, we will get 10.5 square meter times 10,000 square centimeter over 1 square meter. Now square meter will go with square meter, and then our answer will remain in square centimeter, which is going to be 10 like that, 1 2, so which is going to be 105,000 square centimeter. So 10.5 square meter is the same as 105 square centimeter. So we have another question here. I'm going to do only the first one and then you attempt the rest. I'm very sure now you have grasped the concept, but if you have any difficulties, you can visit EasyElimu website where you are going to get all the answers for these questions. So just visit www.easyelimu.com. Now the first question is, express the following into SI unit. So the keyword here is SI unit. Remember, SI unit of area is square meter. It's written as m raised to power 2. So we have been given the first one in square centimeters. So you change it to square meter. So the first thing you do is the relationship between a square meter. 1 square meter is equals to 10,000 square centimeters. Now we have been given 5,000. Let me write properly. We have been given 5,000 square centimeter. How many square meters are there? Because in SI unit means we are going to give it in square meter. So in this case, we will cross multiply. We will have 1 square meter times 5,000 square centimeter over 10,000 square centimeter. So square centimeter will go with square centimeter. Then we will remain our answer in meter, which is going to be this 0 will go with this 0, this one with this, then this 0 with this 0, this 0 with this 0, and then we remain with 5 divided by 10, which is going to be 0.5 square meter. So we have different regular shapes and their area is calculated using a specific formula. Like in the first case, we have a rectangle whose area is calculated as length times width. So a rectangle has two sides. It has length and it has a width. So if you need area, you just take length, you multiply by width. Remember, length is in meters and width is also in meters. So you get your area as length in meters times width in meters, which is going to give you area is equals to length times width in square meters. So you can assign any number at the length and at the width. Like in this case, let's say you have a length as 5 centimeter, then you have a width as 10 centimeter. Then our area now is going to be length times width, which is going to be 5 centimeter times 10 centimeter, which is going to give us 50 square centimeters. Another regular shape that we are going to encounter here is a circle whose area is calculated as pi r squared. So for you to get the area of a circle, you only need to know the radius. For example, if we have a radius of, let's say, 7 centimeter, then the area will be pi. Pi, remember, pi is a constant. It's a constant, which is 22 over 7. Then it will be pi r squared. So area is going to be 22 over 7 times 7 centimeter times 7 centimeter. Remember, in this case, we are going to multiply a centimeter twice. So it's going to give us an answer in square centimeter. So in this case, if we multiply this, it will be 22 over 7 times 49 square centimeter. Then 7 will go 1, 7 will go 7 times. Then now our answer will be area is equals to 154 square centimeters. So in that case, you could have calculated the area. So another regular shape is a triangle whose area can be calculated as a half base times height. So a triangle has two important sides. We have a base and we have a height. And if you need to get the area, you get the product of a base and a height, and then you get half of it. So in this case, if we have a base, let's say 10 centimeter, and a height, let's say 4 centimeter, then our area is going to be a half base times height, which is the same as a half times 10 centimeter times 4 centimeter. Then now these two will go with this 10 to 5. Then we will remain with our area is equals to 5 centimeter times 4 centimeter. Area is going to be 20 square centimeters. So we have other shapes which are not regular, and to obtain their area, you can only do it through estimation. So what you do, you subdivide the surface that you have been given into small equal squares, and then obtain the area as number of complete squares plus a half the number of incomplete squares. So let's do the one on the screen. Here we have how many complete squares. Let's use red to calculate the number of complete squares. This one is complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 complete squares. Area is going to be 12 plus, let's use incomplete squares. Let's use green in this case. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So in complete we have 22. So it will be plus a half times 22, which is going to give us area is equals to 12 plus here 1, here 1, here 11 plus 11 plus 11, which is going to give us our area is equals to 23 square centimeters. Now students, the last question is like the one that we have handled, so I expect you to do it. That will be your assignment after this lesson. So try it, and then if you get any difficulties, visit EasyElimu. There is a link below this video. Then you visit EasyElimu and get answers there if you get any difficulties. For now, that is the end of our lesson today. See you next time when we will be discussing volume.